So tonight we're going to be doing Unit 2, Lesson 8, the practice problems. So the first thing that we have is that we're looking at the relationship between the distance, which they give us as y, and that very same distance in miles. So it's in yards and miles. And the equation that they've given us to use is y equals 1,760 m. So remember, when there's a number next to a variable, it means that we multiply. So, as we should know by now, when we go from left to right, we always multiply. And when we go back from right to left, we always divide. In this case, they told us that the distance in miles, that's over here, m, and the distance in the distance in yards, which is y. We're going from, like I said, left to right. And just like in our equation where it says y equals 1760 m, it's just a very simple substitution for m. So in this first one, I know that I'm going to have 1 times 1760, which of course is going to be 1,760 yards in a mile. Next one. This time I'm just going to do 5 times 1760. And like I've said in class, you can use a calculator. There's no reason to make yourself crazy doing these yourself unless you really want to. And then, of course, you can. But still, please double check your work using a calculator. Okay, so the answer to that one is 8,800. And now we're going back in this direction. So we're going to be dividing by 1760. So we're going to have 3,520 divided by 1760, and that should give you an answer of 2, so that's 2 miles. And the last one, we've got 17,600, sorry about that, divided by 1760, and even without a calculator, hopefully you realize that that is 10. Okay, the next thing they do is they ask us if there's a proportional relationship between the yards and the miles for the same distance. So the simple answer here is because there's a constant of proportionality, and it's the same for every single one of these, that means that it is proportional. So again, it is proportional, and the reason is because there is a constant of proportionality, and I know a lot of you like to just refer to that now as the COP. And the COP in this particular case we know is 1760 because that's what they're all multiplied by. Moving right along, we have to now decide whether or not each equation given represents a proportional relationship. So, the truth be told here, it really is the situations, unless we're substituting in, really are irrelevant. And the only thing that we need to look at is the equation itself. And the only way something can be proportional is if there's a constant of proportionality, meaning to get from one variable to the next, the only options are to multiply or divide. If we do anything else, it's not proportional. So this one, because we're subtracting, this one is not proportional. So it says decide if each one is a proportional relationship. So this one is not. The next one, again, we don't need to really pay attention to the situation itself. We look at the equation. The only thing that's happening between the variables p and t is multiplication. So therefore this is proportional. The next one, we've got x is equal to m divided by 4. Remember, division and multiplication are inverse operations, so that therefore this one is also proportional. Last one, we're looking at this. Now be careful, because you might say, well, s is being multiplied by 12, so that's multiplication. But you really need to make sure that you're paying attention, because s is actually squared before it's multiplied by anything. So therefore it is not proportional. Okay, the next one that we have is they've given us an equation to use to fill in the table. And then it asks us if y is proportional to x and y, and then we have to explain. So the equation that they've given us is y is equal to 5/2 x. So remember, what that means is that when we have x here, we've got 5/2 x here, and 5/2 x is equal to y. So we want to keep that in mind, because I know that there's also been some equation writing, and sometimes that can still be confusing, but that's where that comes from. So very simply, we're going to be substituting in. So they give us x each time, so we've got y equals 5/2 times 2/1. I know that's a 2, but it's over 1. Top with the top, bottom with the bottom, that gives us 10/2, which reduces to 5. So the first one here is 5. Next one, we've got y equals 5/2 times 3/1. Top with the top, bottom with the bottom, that gives us 15/2, which we can leave like that, or we can reduce it. Either way, it is a correct answer. So 2 goes into 15 7 times, with 1 left over. That's 7 1/2. And the last one, x is now equal to 6. So we've got y is equal to 5/2 times 6/1. Top with the top, bottom with the bottom, that gives us 30/2. 30, half of 30, of course, is 15. So the answer here is 15. And is it proportional? It is proportional. The reason we know it's proportional, again, is because the only thing that's being done is multiplication or division from one variable to the next. And we can also just say that the constant proportionality, like I said, COP, most of you have started writing that on your paper, is 5/2. Next one is the similar to the last one, in that they've given us an equation and we're filling in the table.
After I do this on...
Okay, so our equation that we're going to be using is y is equal to 3.2x plus 5. Let's not forget that number next to a variable means we multiply. So the very first one, we've got y equals 3.2 times 1 plus 5. Take this one step at a time. 3.2 times 1 is 3.2 plus 5 is 8.2. Y equals 8.2, 8.2. There we go. Next one. I'm actually going to move it over here. So we've got y equals 3.2 times 2 plus 5. Order of operations, even though it is going in order from left to right with the multiplication and addition, had it not been in that order, we still need to make sure we pay attention to that. So 3.2 times 2 is 6.4 plus 5 more. That will give us 11.4. Y is equal to 11.4. And the final one, we've got y equals 3.2 times 4 plus 5. 3.2 times 4. I've told you, use a calculator if you need to, but you should know that 3 times 4 is 12. And that 0.2, or 2 times 4 is 8, so it's just in its decimal form, 8 tenths, 0.2, 12.8 plus 5 more. 12 plus 5 is 17.8. The last one is 17.8. And that question, we know, asks us, is it proportional? It is not proportional. The reason it's not proportional is because there's no constant of proportionality. If you were to go back and divide 8.2 divided by 1, you get 8.2. 2 times 8.2 is not 11.4, nor is 4 times 8.2 17.8. So you've got a couple of reasons here, but the most basic one is that there's no constant of proportionality. Next, to transmit information on the internet, large files are broken into packets of smaller sizes. Each packet has 1,500 bytes of information. An equation relating packets to bytes of information is given by B equals 1,500p. P is the number of packets, B is the number of bytes. So, the first thing they ask us is how many packets would be needed to transmit 30,000 bytes of information. So, they've already given us the equation as B equals 1,500p. This is 30,000 bytes. So that means they've given us B, so we know that B is equal to 30,000. All we need to do now is substitute in. Every time we see a B, we write 30,000. So that is going to be 30,000 equals 1,500p. Well, how do we solve that? We know the number next to the variable, 1,500 next to p, means to multiply. We ask ourselves always the same question, what is the opposite? The opposite of multiplying by 1,500 is, of course, dividing by 1,500. Make sure you do yourself the favor of writing it like this, because then it's very easy to see how those cancel out. Use your calculator to figure out 30,000 divided by 1,500 if you need to. And you should find that the answer to that is 20 is equal to P. So the answer is that there's 20 packets. And the next thing, how much information can be transmitted in 30,000 packets? So they're using that 30,000 again, just like they did here. But in the first question, they were referencing that there were 30,000 bytes. In the second one, they're saying there's 30,000 packets. So we're going to use the same approach. We have our equation, B equals 1,500p. This time, instead of being given B, we're given P. So we're separating those by a semicolon. We're saying that P is equal to 30,000. We substitute in B equals 1,500 times 30,000. And then once we do that math, we should hopefully see that there's 45 million bytes of information. And the very question, they say each byte contains 8 bits of information. And we're being told to write a new equation to represent the relationship between packets and bits. So the original equation that they gave us, we don't want to forget, is that B is equal to, I'm just redoing that so it actually looks like a B, is equal to 1500p. Now, remember, we know that B is originally let B equal the number of bytes. And we're being asked to write an equation for the number of bits. So we most certainly use this information that they've given us right along. So we know that for every one packet, so one packet, it's equal to 1500 bytes, which they did give us that in the original problem, which is either in front of you in your workbook or on the previous page, which you can turn back to if you need to. But I am giving you the information there. And then we're told that 1 byte is equal to 8 bits. So if I know that 1 byte is 8 bits, and I've got 1500 bytes, in order to find the number of bits, I need to multiply. So there's 1500 bytes times the number of bits in each byte. I know that that's kind of like a tongue twister, but make sure you go back, rewind this if you need to, and understand where each of those numbers is coming from. The 1500 is the number of bytes, 8 bits because there's 8 bits per 1 byte. So if I go ahead and multiply those, I am going to end up with 12,000, sorry, I read my answer a bit wrong. So 12,000 bits. And I know that those bits, because there's 1500, remember where our numbers came from, this is per 1 packet. So 1 packet equals 12,000 bits. So I need to choose a new variable because we already have B here for the number of bytes, and we're writing an equation for the number of bits. So the first thing I'm going to do is say let x equal the number of bits. And just so that we don't forget, we're going to say let p equal the number of packets. And again, this is already given information, but we don't want to forget. So, just like here when I was looking for the total number of bytes, I multiplied that number times the number of packets. In this case, I'm looking for the total number of bits. So I've already found that in 1 packet there's 12,000 bits. So I would therefore, just like in the original, multiply that number times the number of packets. So my new equation is going to be x, because that's the total number of bits, is equal to the number of bits, which is 12,000 per each packet. And that will, of course, give us the number of bits. So your final equation is this right here. But you do need this information here as well to tell us what each variable means.